The less energy a city needs, the easier it is to supply that energy sustainably. As we'll see today, design, arranging built objects in relation to one another, is the single most important factor in reducing a city's energy demand. The beauty of design is that it can accomplish many things at once. The same design that can make a city 88% more energy efficient can also make it far safer, healthier, wealthier, and better for the planet. Welcome to Edenicity, best practices for sustainably abundant cities. Energy comes in lots of forms, so there's many ways to measure it. There's joules, kilowatt hours, calories, British thermal units or BTUs. We'll talk a lot about those today. Quads, the list goes on. Power is how quickly you use energy, and 1 watt of power is 1 joule of energy per second. A kilowatt hour that you see on your electric bill is equal to 3,600,000 joules. A kilowatt hour is also equal to 3,412 British thermal units or BTUs, and a quad is a quadrillion BTUs, which is equal to 1,055 petajoules, or about 10 to the 18th joules. Here's the energy production and use for the United States in 2022. It's one of many Sankey diagrams prepared by Lawrence Livermore National Laboratories. See the description below for the link. Lawrence Livermore has also created Sankey diagrams for many U.S. states and many other countries over a span of quite a few years. But look at this. 2/3 of the energy that's produced in the United States is rejected. What does that mean? Anytime you convert energy from one form to another, or move it around, some of it is lost to heat. This is rejected energy. The more efficient your energy production, conversion, and transmission, the less energy you'll lose. The U.S.'s 33% efficiency is actually pretty low compared to many other countries. Let's convert these U.S. energy numbers to something a person can relate to. We take the total U.S. energy use, convert it to kilowatt hours, divide it by 12 months, and then divide it by the population of the U.S. to get the average kilowatt hours per person per month that are used in the United States. Now, if you look at your electric bill, you'll realize that 2,400 kilowatt hours per person per month is actually really a lot. But remember, this includes all the energy you use in your home, as well as transportation, and all the energy that went into making everything that you buy and powering all the activities you engage in. The total U.S. energy consumed came to about 100 quads in 2022. Now, a quarter of that was lost in electric energy generation and transmission before anyone could put it to use. We'll talk about electricity supply in the next episode. But for now, let's focus on demand. Topping our list is transportation, and this is an area where we can really see the power of design. Remember, our design is car-free and multifamily, meaning no detached houses. That alone lets us increase the urban density, the number of people per square kilometer or mile, by a factor of 4. These design choices also make the city far safer, greener, and 4 times quieter, so it feels less crowded. How much energy do these design choices save us on transportation? Density is dwellings per area, and area is the square of distance. So at 4 times the density, all trips are half the distance. That's going to cut our energy use in half right there. In addition to that, mixed-use development puts shopping, schools, dining, clinics, and many jobs within walking distance. That cuts motor vehicle trips by at least another 50%. Intercity rail uses 14% as much energy as cars. Multiplying these factors together cuts our transportation energy use by an astonishing 96.5%, at least within the city. That cuts the amount of energy a person uses for transportation from 1,600 kilowatt hours per month down to 57 kilowatt hours per month. Now, in the early days, as cities upgrade to Edenicity, their main focus will be supplying their own energy, not anything beyond the city. Let's call this Edenicity Phase 1. Cities that are upgrading to Edenicity would be wise to link to intercity bus or rail networks as soon as possible. Rail uses 86% less energy than cars. It's also 17 times safer, 10 times cheaper, and somewhat faster than cars for intercity trips up to 1,000 kilometers. At this point, I made a detailed model of Edenicity, including intercity rail, with these assumptions. On any given day, about 20% of the population makes a round trip by tram, and 16% makes a round trip by metro. Remember, far more people are walking or biking because of how the city is designed. In addition to that, the average person travels about 40 intercity legs by rail per year. Just for perspective, a one-way coast-to-coast trip would be about 15 intercity legs worth of travel. With these assumptions, the model gave a total transportation energy demand of 65 kilowatt hours per person per month, pretty close to my estimate of 57. So let's include intercity rail in Phase 1 of Edenicity. Now, if you're wondering about long-distance air travel, I'm saving that for Phase 2, which I'll discuss 3 episodes from now. What about buildings? Commercial and residential buildings consume a total of 22% of the energy we use, going from single-family detached houses to multifamily mixed-use homes saves energy in 4 ways. There's only a third as much exposed roof area per resident. There's half as many walls to insulate. There's less volume to light, heat, and cool because of shared amenities, such as gyms, libraries, hobby rooms, pools, dining, and entertainment. And the shared equipment, such as restaurant kitchens, is higher efficiency due to economies of scale. Now, I would contend that most apartments and townhouses today don't make full use of items 3 and 4. But even so, they consume 52% less energy than detached houses that make up the vast majority of dwellings in the United States. Going all in on items 3 and 4, I think the improvement could go as high as 55%. In addition to that, since buildings spend 30% of their energy on heating and cooling, better insulation and a tighter building envelope could bring that way down. The passive house standard is 80%, but it comes with significant limitations on landscaping, orientation, and air handling. 50% gives us a lot more flexibility in a high-density situation. 50% of 30% is a 15% savings. Now that we've made it easier to heat and cool a space, we can actually use better technology to do so. A high-quality heat pump is 3 times more energy efficient than the baseboard or gas heat that's found in 87% of U.S. houses. Where I live, upgrading to a heat pump would cut my energy use by 32%. 87% of that 32% is 28%, rounding down. The next biggest item to improve is lighting, and it's amazing how many buildings still use fluorescent bulbs or even in some cases incandescent lights. Upgrading these to LEDs more than doubles lighting efficiency. Lighting accounts for 10% of home energy use, so upgrading the lights can save 5%. Green roofs, which are a major part of the Edenicity concept, can cool a building's roof by as much as 18 degrees Celsius in the summer, that's 34 degrees Fahrenheit, and provide a little extra insulation in the winter. Shade and condensation effects on tree leaves, as well as the extra moisture in the soil due to the presence of trees in the landscape, moderates neighborhood temperatures by similar amounts. In temperate climates, this could easily cut the number of days where people use air conditioning in half and reduce heating by a little bit in the winter. Since air conditioning alone is 16% of the typical household energy budget, landscaping can save us at least 8%. So far, this is all proven technology available at scale, perfect for Phase 1. In a few episodes, I'll discuss emerging technologies that may improve these numbers a little bit in Phase 2. Let's add these up. Actually, you can't. Let me show you why. If you had 2 items that saved you 80% and 50%, it's not true that together they would save you 130%. That's just not physical, that it would give you back more than you started with. Instead, what we need to do is take the amount actually remaining after you take out each of the discounts, and then take those remaining amounts and multiply them together. So for example, 50% of 20% is 10%. That works out to a 90% savings. This is actually what I did in the way I phrased the transportation numbers earlier. Now for buildings, the energy savings add up like this. And as you can see, Edenicity homes use 76% less energy in Phase 1. Okay, let's look at industry. Actually, Edenicity won't focus at all on industry in Phase 1, just buildings, transportation, and agriculture. Now, there is a bit of a gray area. Phase 1 may include light industry, but this will probably behave like commercial buildings, which I've already discussed. Edenicity won't power heavy industries until Phase 2, when these large industrial areas in gray come online. I'll cover those in a later episode. And while I have this graphic up, I want to emphasize again that yes, this is a grid, but no, when you lay it out on a landscape that's curvy, it won't be gridded at all. It's just much easier to understand and draw a grid. Let's add up the energy demand for Edenicity Phase 1. We're just looking at buildings and transportation. When we do that, we see that we've reduced our energy demand by 88%. And if the whole country did this, we would go from 50 quads down to 6 quads. Here's the wild part. The U.S. already generates 8 quads with sustainable energy, with wind, hydro, and solar. So we're already within the renewable energy production budget of the United States today. Here are those numbers in terms of personal energy use. Instead of using 3,600 kilowatt hours per person per month, Edenicity gets us down to 450 kilowatt hours per person per month. That's how much Edenicity needs to generate. The real question is, can it do that within city limits? With renewable energy? We'll figure that out in the next episode. Take care, stay green, see you next time.